Hello students, let us see Newton's second law of motion. And Newton's second law of motion is very important in the sense it gives you the acceleration of the object. So according to Newton's second law of motion, the acceleration of the object is resultant force acting on the object divided by mass of the object, or the net force acting on the object divided by mass of the object. And let us see its different application. Second laws of motion. Right. Now the acceleration of the object can be given by the vector sum of all the forces acting on the object divided by mass of the object. This is the Newton's second law. The acceleration of the object can be given by vector sum of all the forces acting on the object divided by mass of the object. This can be also written as resultant force acting on the object divided by mass of the object, or I can also say this is net force acting on the object divided by mass of the object. Now if you see the resultant force acting on the object is 0, let us say, if I say the resultant force acting on the object is 0, then what will happen? The acceleration of the object will be 0, or I can say the velocity of the object will be either 0 or constant. Is it? And this is first law. Right. So let us see at different places how can we apply Newton's second law of motion. Now in case of one example I'll take, in case of lift, let us take, this represents a lift. Right. And suppose a mass is hanged from the string in this lift, this is mass. Or let us take another mass is there which is placed on the floor of the lift. Let us take, this is placed on the floor of the lift. Now a man is there inside the lift, right? Man is standing inside the lift, that is B, and another man is also there but not in the lift, who is on the ground. Who is on the ground? This A. Now when you observe here, suppose this lift is accelerated in downward direction. Let us say this lift is accelerated in downward direction by A naught. Now when this man A sees this block, he wants to write down Newton's second law of motion. So we'll first draw the free body diagram. What is free body diagram? In free body diagram we represent the object as a point mass, and then we represent all the forces acting on the object. So if you take the free body diagram, you will observe the tension is acting up here on this mass, and this is the weight of the object acting in downward direction. Now I can write down here Newton's second, according to Newton's second law, I can say the net force on the object is mg minus T, and this will be equal to mass into acceleration, or I can say the tension in the string is equal to mg minus A naught. Is it? This can be written according to Newton's second law. Same way, when you take the normal reaction, here the floor will exert normal reaction on this, and weight will be acting in this direction, mg. So I can say the normal reaction can be also written as mg minus A naught. Right. But when man B sees this mass, he says it is at rest. For man B, he says this block is at rest. So T equals to how much? Mg. Then only it will be at rest. It is the force T is acting in upward direction, weight is in acting downward direction. So T equals to mg. For this block, he will say N equals to mg. Now I am getting two values of tension. At one place I am getting G minus A0, another place I am getting T equals to mg, same way, normal reaction, I'm getting two values, mg minus a naught. Now somewhere some mistake is there because the same string is there, but we are getting two values by applying Newton's laws of motion. So what is the discrepancy here? What is the problem here? Why we are getting two values, one value for B, another value for B? What is wrong value? Now the wrong value is attached with the B. Why? Because B is here comes the concept of frames. Here comes the concept of frame, inertial frame and non-inertial frame. Now for B, this B is not in an inertial frame. What is inertial frame and non-inertial frame? First let us see. Now I can say inertial frame are those frame which are at rest or moving with constant velocity. Inertial frame are those frame which are at rest or moving with constant velocity. Now Newton's first law and second law can be directly applied in inertial frame. We can directly apply first law and second law can be applied directly in inertial frame. But what is non-inertial frame? Non-inertial frame are those frames which are accelerated frame. Inertial frames are also known as unaccelerated frame because their acceleration is 0. So unaccelerated frames are inertial frame. Accelerated frames are non-inertial frame. Now when we are applying Newton's laws of motion in accelerated frame, there we have to apply a pseudo force. So since B is sitting inside a accelerated frame, so we'll apply a pseudo force here. Now what will be magnitude and direction of pseudo force? Pseudo force will be acting on the object in a direction opposite to the direction of acceleration of the frame, and the magnitude of the pseudo force will be given as mass into acceleration of the frame. Now after applying the pseudo force on the object, we can apply Newton's second law of motion or first law of motion directly there also in non-inertial frame. So in non-inertial frame, while we are writing the Newton's laws of motion, we have to apply a pseudo force. So for B, when we apply a pseudo force here, that is in upward direction, acceleration in downward, so pseudo force will act in upward. Now then I can say here, for this T plus ma naught is mg, and then I can say T equals to mg minus a0. Same way, when you apply a pseudo force here, the normal reaction for B will become mg minus a. Now for B also I am getting normal reaction same as when A is finding out, and for tension is same as A has found. Now without applying pseudo force, when B was applying Newton's law of motion, that was wrong. So always keep it in mind to frame, inertial frame, non-inertial frame. In inertial frame, you can directly write on Newton's first law, second law there. But in non-inertial frame, you always apply Newton's law after application of pseudo force. Thanks. In next class, we'll see application of pseudo force there.